Okay, thank you. I think everybody can hear me now, right? Patricia Goldberg. So today I'm going to talk about Dagster. So who people were here before, we had already another orchestration tool, the temporal before this talk. Dagster is more specific for data stack, so it's similar to Airflow and Prefect. And today is going to be like an introduction to the tool itself. So the agenda, I'll talk first the data stack tool that we currently have in my company. And then what is actually Dagster? Who is it for? Actually, who is using Dagster? The main use cases, and then a little bit about testing, and then how we can go to production using Dagster. Just before that, a little bit about me. I'm originally from Brazil, but I've been living in Germany for a while, since 2017. I did my master's in Germany. I just stayed after my master's. I'm currently a data engineer / analytics engineer at Vemolo, which is a startup in Munich. And this is my dog, Luna. Okay, so let's put Dagster actually in a stack. This is the simplified two stack we have. So we have a lot of sources. We have Postgres, Salesforce, and Personio, so and much more actually. And then we have Python in the middle, doing transformation, then sync. And Dagster is also in the Python side, so it's on the orchestration too. We load everything into our data warehouse. In the case, it's BigQuery. And we have a BI tool called Metabase that connects directly to BigQuery. But now, today, it's only and mainly just about Dagster. So I won't talk about any of the other stack data libraries in our stack. Okay, so like, what is Dagster and who is it for? So I said in the beginning, so it's a data orchestration tool. So it's not only orchestration tool, similar to Airflow and Prefect. It is Python-based, so you can program it in Python. And it's basically a framework to build data pipelines. Includes the ELT or ETL part, so you can extract, load, and transform inside Dagster. But also you can have external services like sensors. You can also store some metrics in Dagster itself. You can have alerts and monitoring. You can also include data quality checks inside it. And obviously nowadays you can also do machine learning assets, so it does increase a lot the capabilities of Dagster. Now it's who is it for? So I actually took this image from Dagster. They use it like in the website. It's mainly based for data engineers or machine learning engineers. It does not mean the other people cannot use it. It means that the focus and the maintainers of the repository, of Dagster repository, in theory should be people that knows data, a lot about data, but also knows how the software engineering process can be used into data. Because it is tech savvy, so it is very, like it's Python. And if you do open source, like we are using open source, you also have to think about deployment and then support and then resources, usage of resources. So in our case, we actually have everything in the data practitioner using Dagster, but we data engineers, we do the maintainability of the servers and the resource management. So in theory, it's only Python. If you use the cloud version, if you want to pay for it, you can just pay for it, and then you don't need to think about the rest. But if you want to use the open source, you do need to think where you're going, so which cloud provider you want to use, how to do proper GitLab or GitHub actions, how to do code maintainability, and how to connect to each database that you might have. So you might have Postgres, you might have BigQuery, you might have Snowflake. And everything together should be combined together with Dagster. Dagster is in the middle of everything. Okay, let's go to the use cases, right? There are more than these four. I only brought these four because these are the one that I use the most, like daily. We have the schedules, meaning something needs to happen at a certain point. We have, they call it assets, but asset is basically like a table or a file somewhere. Sensor is what I said when something happened outside. So for example, a file appears in a bucket. You can add a sensor to see if this file is new and then do something else. And resources is how you communicate to external resources. If you talk about like BigQuery, for example, is a resource, how you connect to BigQuery. In the same structure that we had before, right? So we have the sources, we have Python in the middle doing a lot of stuff, and then we have BigQuery in the end. I can say that my resources are, for example, Salesforce. My assets are table orders that is coming from Salesforce. It's stored in Mercury. But this table, I only want to be updated daily, for example. But then when this table updates, I want something to happen. What's something happen? For example, you can send an email. You can do like a report. And this is the sensor. So sensor waits for something to do something else, regardless on when this happened. Now a little bit of code, just to put idea on how to do it. For example, we have resources. This is an example of Salesforce resources. It's not executable, by the way, so you cannot run this. It's just an example. But a resource means I have an input from the user, for example, a username and password, and then I connect to something, for example, a Salesforce endpoint. And then this is my request. And then I just say to Dagster, OK, I have these resources. So whenever in my code base I use name Salesforce and resources, it knows I need to use this request here in this format. One thing I still haven't mentioned is that Dagster also provides this web server, which you can see what you program, but you cannot change anything in the web server. So you cannot change any resource there, but you can see the resource that you have already in Python. In my case, I have a Salesforce resources, so I can go to resource web page in Dagster, and I see Salesforce resource. Nice. But you see, there is no description, and my password is like pure value. So if I put this web server to other clients or other people in my company, everybody can see the passwords. This is not good. So we have to take care of your code whenever you're putting something in Dagster. And for example, you can have a description. In Dagster, you can just add a doc string to the class of your resource. It's already a description. And you can change the password to be an environment variable. Going back to the UI, now the same doc string that you had in your code, it will appear in the Dagster web server as the description of the resource. And also the password is not anymore explicitly, but rather just saying, OK, I have a password. Right? There's nothing else. I have a password. OK, so now I can connect to Salesforce. But then I want to get something from Salesforce. I want to get data from Salesforce. In my case, I want to get orders. So using my resource as a parameter here, this is my resource Salesforce, I can do the request to the endpoint orders. This returns for me all the orders. Furthermore, I can have more information using this order. So I can do reports afterwards, or do calculations, or do KPIs. So for example, I have another asset that my depth is order. So I have a dependency on this order. That my owners, you can also have team as owners, for example, is sales. And then I do something with this report. Again, I just tell Dagster, OK, I have these assets now. If you go to the UI, it provides already everything connected, so all the assets that you have defined with the dependencies. So if you open one of the assets, you can see directly the weekly orders depends on orders. And I can materialize at each one independently, or I can also materialize everything upstream, everything downstream, directly here from the UI. Again, so if we put this web server to more people rather than just the data team, we do need description everywhere. So I'm also adding descriptions here, and I'm making sure that these assets are Python assets, because you can also have SQL assets inside Dagster. Nice. If you open each asset individually, you can also see the same description that you had before in the asset itself. You can see, again, the lineage here. Furthermore, you can have more metadata information in here. For example, that is using the resources Salesforce. The same for the next one, the downstream model, which is weekly orders report, which does not depend anymore on the Salesforce, but rather just depend on the upstream assets order. And it is owner, there's an owner tags in here from sales. So if something happened to this asset, I know I have to contact somebody from sales, for example. Nice. And now I have the code. I need to execute it automatically. I don't want to go every day and execute it. And it's simple as that. I just add a schedule. In this case, it's just a daily schedule. It's very simple. define, yeah, I need to also say, define the selection of all the assets. You may have something that you execute daily, you may have something that you execute hourly. The same thing that we had before, we have still the DAG here, the dependencies, but then we have a daily refresh that in the UI, you can activate and deactivate the schedule. This you can do in the UI, but you cannot change the schedule itself. You cannot change from daily to hourly. Also saying that I do have still a resource Salesforce. This is what my assets depend on this case. So my schedule here, yeah, and then let's continue. So after everything, you might still want to do something. So you might want to still send an email, for example, with the report that you created before. And this is where the sensors enter. The sensors not only things happen inside your repository, inside your Dagster, but also can be something from external. In this case, it's something that you already did. And I'm doing an asset sensor here, meaning I'm waiting for the asset key weekly orders report to be materialized. So whenever this table is updated in BigQuery, I call another job, I call another thing, which is called send email. This will just send an email, for example, if you have a new data from weekly orders report. The return of this is the run of this job specifically, and with a run key. This run key in Dagster is unique. So if you don't want something to execute it twice a day, for example, you just put the run key as date, something like that. And then if this happens again, if this report is materialized twice in the same day for some reason, you won't send the email twice a day. So you just send once a day. And then again, we can go to the UI and see the same sensor. You can see that actually this is monitoring specific assets. If you have a list, it will be all the list in here. And then the target will be send email. So the job that will execute it after the sensor is triggered is the send email. Right, so now I think I have everything that I needed in a daily life, but we also need to test it, right? So it's not only programming, but also need to check if everything is correct. One thing that they provide is this, they call it asset checks, but if you're in a data world, sometimes you call it data test. So data is the test of the data itself. If the data is unique or not null, or for example, accepted range of data. The data should be materialized already, should be already in a database to do these asset checks. Data freshness checks, it is something that if you do something daily, you need to expect this to be updated daily. If it's not updated daily, then you probably have an alert. For example, I'm missing Salesforce connector, something happened. Unit testing, on the other hand, is more towards the Python code itself. It's more traditional software engineer. The same is for testing configurations and job. The asset checks, you can do very similar code as before. We do also a decorator called asset checks, and which asset this is actually testing in the decorator itself. You do need to read the data from the database because it's, again, is a data test. And then you have to also program your test itself. The return is if there's something that is not unique in this, it has nulls actually, this is not null. If there's something that is null, then I have this sum of plus 0, so it's not 0 anymore, and then my test will fail. These asset checks you can do actually whenever you want. So at the moment we are doing for each execution of materialization of each asset. So we do it every time we execute it. So if it's 10 minutes, we do 10 minutes asset checks. And in the UI, you can go to the asset itself and then just check the latest execution and also how many times this failed or not. You can also manually execute something in here as well. Okay, from the deployment itself, I won't go further because it can be very complicated and depends on the stack that you have. But I do need to say that you need to choose the cloud provider that you want. With that, you can also choose if you want a Docker, there is a simple Docker image that you can use, or if you want to go to Kubernetes to be more stable and more scalable. That's it. Can I?
Use the water? Yes. No? So thank you. Maybe we can have a question session. Do we have some question from the audience? Okay. Just second. A little bit support. Yes, please.
So given that the last talk was also about an orchestration tool, how would you compare Dagster to Temporal, and what would be the key differences from your point of view, or maybe the key different use cases for both of them?
Sorry, I haven't used Temporal, but from what I understand, the Temporal is more to the data flow. Oh, I need to stay here, sorry. And Dagster to the data pipeline. Dagster is more similar to Airflow. Yeah.
More question we have? Sorry.
So following question, you mentioned Airflow. So how it is related to Airflow? What is the main difference? Let's say we are using Airflow and want to move to Dagster. What are the benefits and what are the minuses?
Yeah, so I used Airflow before choosing Dagster. I didn't migrate it though. I used it in the previous company. Dagster, in my opinion, is more Pythonic. I think it's easier to program in Dagster than Airflow, to be honest. The UI also, it's very easy to understand. There's not so much knowledge, prior knowledge you need it. Airflow is more, it's older, so it's more stable, I would say. If you're not in adventure of finding something new, I would say don't change. But if you want to find something new, I think Dagster is a good choice. I really like this idea of asset-based, which Airflow does not have, right? Airflow is more like DAG-based. But at the end, Dagster was after Airflow, so it was highly based on Airflow, to be honest.
Thank you. Maybe we have some more questions. It's a good choice just to ask a speaker, not from the.
Yes, I have one question. So, how do you handle the user access on Dagster? Like, do you have a specific audience in the company who should access Dagster interface, or that's open to everyone's?
It's not open to everyone, but we do have the password available for all the engineers. We basically have a very simple authentication flow that is only like one password, and then whoever in the engineering department can want to access, they can have access. Because in the UI you don't do much. You max you can do is just deactivate a schedule. So, and then okay, like we activate it again, right? So it's not so much troublesome. But also the whole company would be too much. Like it would be a lot of access. I think there's another one.
Yeah, I saw one more hand.
Yeah, I'm just really interested in how sensors work and whether like they're supported by different, like, is it only like certain types of databases that are supported out of the box or not, and whether like we could make something of our own?
What about resources, right? Sensor is
well, like if something changes in a database, would the sensors pick that up, or does it have to be a specific flavor of database for it to do it?
They do provide some specific libraries for sensor and not for database. Like they provide the sense of asset. So if you run your asset inside Dagster, it does know what's happening. But if there's something else externally, you have to have a specifically sensor for it. And you do have, for example, for S3 bucket. They do have for some bucket specific. So if a file appears in the S3 bucket, the sensor will be triggered, and then you can do the job that you want. For the others, you can actually do yourself. It's quite open to create a new sensor. Like it's not so hard to create a new sensor. They have a base class that you can just inherit it and then go from it. If you need something in a database that's not controlled by Dagster, for example.
Thank you. Do we have some more? I think I saw one more hand. No. Seems no. So thank you for such amazing talk.